In this video, I'll go over how to use the geometry solver to deform the ground like this and give some insight into how solvers work in Houdini. You can use this setup for a variety of different animations. Previously, I covered how to create the sparks. There is a link to that video in the description below. So now let's deform the ground as the box hits it. But first I'm going to version up, so we don't overwrite anything. So version 3. Then I'm going to go into the system. And in here I want to hide other objects in the viewport. So we just have whatever is here. So this is our ground that we made earlier. I'm just going to bring the box down here. So I'm going to do an object merge. Just going to drag and drop this one into object 1. So we got the box here. And let's just merge the two together just to take a look at it. And let's see where the box goes. First of all, I want to subdivide the grid just where the box goes. So I'm going to put down a group in here and just template the box so we can see it. And the box goes in a straight line like this. So I'm just going to use this bounding box option. And we should get a box somewhere in the scene view if you press enter. And now I'm just going to increase the size of the box. You can also adjust these parameters, but I prefer these ones. I really just need whatever is going to possibly deform as the box passes through. Something like this. And then I'm just going to name this group something. So let's just say subdiv. And now in here, since it's a primitive group, you can see it in here, subdiv, and it has some primitives in the group here. You can also see it in the info card, subdiv. I'm going to put down a subdivide and move the blue flag. And in here, I'm going to set the group to subdiv. And maybe we can subdiv it a bit more, 3 times. Let's check how many points we have. We have 10,000 points, that's okay. Maybe we can narrow down this box a little bit more. Yep, it's okay. It's a pretty close call, but yeah, that's fine. I want to subdivide some more, but I want to narrow down only where the box is hitting the ground. So for that, I'm going to use a subsolver or a geometry solver. First of all, I'm going to create an attribute both on the grid and on the box. So I'm going to put down an attribute wrangle. And it's going to be a float. I'm just going to name it subd, and I'm going to set it equal to 0 on the grid. So now we have an attribute on the points. That's subd, and it's just 0, and it's on the point. Then on the box, I'm going to do the same, another attribute wrangle. I'm going to call it the same. It's going to be a float and at subd, and I'm going to set it equal to 1. Then I also want to give the box a bit more topology, so I'm just going to remesh it. Let's see how it looks. Maybe we can remesh it a little bit more. Something like this. I'm going to do an attribute transfer. So I'm going to transfer the subd attribute from this box to the grid. So I'm going to put down an attribute transfer. And the grid goes in the first input, and the box goes into the second input. Move the blue flag. And then I'm going to untoggle primitives because we don't want any primitive attributes. And then I'm going to just choose the subd. Now to look at it in color, I'm going to put down a color node. And in here, I'm just going to say ramp from attribute, and it's going to be subd. You can see we have this big area, and you are close to the box. I want to decrease it. So inside of the attribute transfer node, I'm going to go into condition, and I'm going to take the distance threshold down. I just want a little bit, just close to the box. So we can look at the two together. Something like this. So there's a little white area around the box everywhere. But I would like to accumulate this white area. So when we get to the end, everywhere where the box has to be close to the grid should be white. And to do that, I'm going to use a solver. And we can move the color until after. Just going to cut this and move the blue flag. And then move this wire to the solver node. Inside of here, you can have the current frame, which is input number 1, but you also can have the previous frame. And that is just the previous frame in the timeline. So on frame 19, the previous frame will be frame number 18. On each frame, I want to check the previous frame and ask, was subdiv 1? And if it was 1, keep it as 1 instead of 0. And to do that, we can just put down an attribute wrangle. And I'm going to plug the previous frame into the second input. Then in here, I'm going to say float attribute subd is equal to the maximum of these two inputs, and one of them is the subd coming through here. So f at subd. And the other one is subd coming from the previous frame. And to do that, I'm going to use a point expression. We can see what it needs. It needs to know where the geometry is coming from. It needs to know the name of the attribute, and it needs to know the point number. So the geometry is coming through the second input, so it's 1. The name of the attribute is subd. And since we're just comparing every point to the same point, the previous frame, we can just say at pgnum. So it's just the point number of the current point. Something is broken because I forgot the bracket. So now we can go upstairs, see how this looks. So as the box goes through, the subd attribute will stay as 1 everywhere where the box has been close to. So we have a little bit of stepping, so we might want to add a little bit of substeps. But if we're gonna add substeps, we have to check if this box animation has subframes. So I'm just going to go into the animation options, and I'm going to untoggle integer frame values, and the step is then set to 0.1. So now as you step through the timeline, you have subframes. So we do have actually substeps, so that's all good. So I'm just going to set this back to integer. So now we go through integer values in the timeline. And let's just increase the substeps to 2. We can reset the simulation. And we have a smoother path. So what I'm really interested in is the last frame, because I don't want to be subdividing the grid throughout the simulation. So I'm going to just put down a timeshift. And in here, I'm going to delete this channel and just keep it as the last frame, 80. And now I'm going to put down another subdivide. And inside of here, I'm going to say group. And my group is going to be whenever this subd attribute is equal to 1. So at subd is equal to 1. And nothing happens because it's a point attribute. So we would actually like it to be a primitive attribute. So let's go back up here and put down an attribute promote. And the attribute I want to promote is the subd attribute. It used to be points, but I want it to be primitive. And as we change this, notice the subd attribute is going to disappear from the geometry spreadsheet. And it's going to appear in the primitive section of the geometry spreadsheet. And we can move the color down too. And in here we just have to change the class to primitive. You can choose your promotion method since there are more points than primitives. I'm just going to take maximum. And now, when we look at the subdiv node, you can see everywhere where subdiv is 1 has been subdivided. And maybe you want to subdivide it once more. Let's check how many points we have, 44,000. That's all good. Maybe another time. Something like this. And now the only thing we have done is to subdivide the ground, but the ground is still flat. So let's actually deform the ground. I'm going to bring in the box again, so you can just copy paste this object merge. We can take the remesh node as well. So we got the box that we're basically just picking up from up here. We remesh the box. And now let's just ray the ground on this box. So I'm going to put down a ray. Find some good frame to see what we're doing. And then I'm going to connect the box into the second input of the ray. Move the blue flag. And in here, you can hide the guide. So now it's raying the box upwards, but let's change the direction source to a vector. And here we got a channel, so let's just delete this channel. And let's say 0, -1, 0. So it's just going to take this grid and ray it onto the box in the direction of -y. So now you can see a little bit of a dent. And now the box is very square, so let's give it a little bit of a mountain. I'm going to try out some element size, maybe do something like this. Take the amplitude a bit down and then add some roughness back in. Something. And let's check the ray now. Okay, we got to something a little bit more interesting. And again, I would like to accumulate this deformation, so I'm gonna again use another solver node. So down here, I'm gonna put down a solver. And let's dive inside. And again, I want to check the previous frame. So I'm going to check the attribute py, and whichever value has the lower value is going to be exported through the out node. In this case, I'm going to use an attribute swap. I'm going to connect the current frame into the first input and then the previous frame into the second input. Inside I have the P that's coming inside the node and then the P that will be coming out of this node. So I want to break this vector up, so x, y, and z, so I'm going to say vector to float. Vector to float. And this will give me access to x, y, and z. And then before exporting it, I'm going to do the opposite. So I'm going to assemble the vector again by doing a float to vector. And then I want x and z to stay unchanged. but I want to do something with y. So to pick up an attribute from the second input, I can use an import point attribute node. This one. And then I'm going to connect the second input to file. You can also set it here to second input. Attribute is already set to p, so that's good. But I just want the y component, so I'm going to put down a vector to float again. Vector to float. Connect it. And now what I want is basically whichever one of this or this value is lower. So I'm going to put down a minimum node and connect both of these to it. And then I'm going to plug this into the y we're going to export. And let's go upstairs again. And let's play the simulation. And you can see the deformation is preserved. There is a lot of stepping, so let's add some subframes. So on the solar node, I'm going to set substeps to, let's try 3. It's going to take a little longer to simulate. It's a little better. Maybe you want to go up to 4. Something like this. And what you really want to be doing is looking from the camera. We still have the subd attribute. So if you look in here, so I think I'm going to use that again to subdivide just this part once more. So I'm going to put down a subdivide node, connect it, and then in group I'm going to say attribute subd is equal to 1. So now you can see how it looks. Something like this. If you want it to look smoother, we can use a smooth node. If we use it before the subdivide, it will smooth it out more. Or if you use it after, it will preserve more of this harsher angles. Or you can just see what you like. Or you can skip it. It's up to you. It's also good to look how it looks after rendering. It's going to give you a better idea. And so now we have the deform ground, and since the simulation is a bit heavier than the particle simulation, I'm just going to write it out to disk. So I'm going to put down an wrap geometry output. And this is going to create a folder called geo, and then this is going to be the file name, but I'm going to copy paste this because I also want to create a folder under these files. And I want to render the full frame range, and then I want to change the name of this node, so I'm going to call this deform ground. And then if you middle mouse click on output file, you can see that we have geo, and inside we have a folder named after the file name and this node, and then we have the files over here. Let's save it out to disk. And we have a geo folder here, and inside the deform ground. Let's read it back in. So I'm going to put down a file node. Here. Connect it to the render ground. So it looks like this. Something like this. Let's clean up the attributes. So we had this subd attribute. It's a primitive attribute, so it's in here. And then I just want to delete the group as well. subdiv. Then I'm going to calculate the velocity of the ground as it's deforming. It doesn't really matter, but let's just put down a trail. And in here I'm going to say compute velocity. And now if you take a look at the velocity vector here, if you turn it on, you can see the velocity. You can see how the ground is being deformed. So what this node does is basically compare the position of each point on this frame to the position of each point in the previous frame, and then creates the velocity vector from that. So if you're using the trail node to compute velocity, it's very important the point count stays the same between frames. And that's also why we couldn't be subdividing the grid on the go, but we just took the grid as it was on the last frame. So now we can go to Solaris. I'm going to hide the velocities, save the scene, and go up a level. And you can see this node has been updated because we are picking up the render ground node, which is this one. Then in states, we have the deform ground as well. I'm going to hide the grid and set the camera. And let's change the view to karma. And if we go a little further on, we can see the deform ground. Just to be proper, I'm also going to add the velocity blur to the grid here, where we set the velocity blur to the sparse and the render box. So slash render ground. I versioned up, so I won't overwrite the previous render, so that's all good. Then I'm going to revert the frame range back to default. So we are going to be rendering from frame 1 to frame 80. Save the scene and hit render to disk in background. And then we can take a look at the render scheduler. And we have the render here. And then here inside of the render folder, there is a new folder. And inside of it, the rendered frames are stacking up. And we got all the frames rendered out. So let's take a look at them in mplay. We got some sparks, and we got some ground deformations as well. If you want to be a bit picky, you might want to think about the sparks colliding with a deformed ground, not just with a flat ground. But that would require bringing in the deformed ground into the simulation, and I don't think it would be worth it. You could also take down the life of the spark, so it'll disappear quicker. But I think for this exercise, I'm just going to keep this as it is. I'm going to cover the box simulation in another video. And other than that, just please like and subscribe. Thank you.